So continuing on with the 1.7 notes, let's look at an example like this. This isn't on your paper, so just look at the screen and think, what do you do in a case like this? You have your absolute value, you have your less than or equal to, it kind of combines everything together. So let's do like we would normally do with an absolute value problem. We're going to take the 12 and we're going to turn it into positive 12 and negative 12, just like before. That whatever's inside the absolute value stays the same. The x stays the same here and here. But what changes is this sign. It's no longer equal to, it's less than or equal to. So when it's positive, that's fine. Nothing changes. But when the 12 has turned into a negative 12, you've basically multiplied by negative 1. And anytime you multiply by a negative number, you have to take this sign and flip it so it becomes greater than or equal. The last thing you're going to need to know for this lesson is if this becomes an or statement or an and statement. So here's the rule. When it's less than, you're going to make it and. And so you would graph this and you would see how it ends up looking. And here's the rule in general. Less than means you use and. They kind of rhyme, than and and. Greater means you use or, and they kind of sound the same. So that's how you're going to know which kind of a statement to make and what your graph is going to look like. Less than means and, greater means or. So looking at our first example that is in your notes, go ahead and pick up your pencil and write this one out with me. The absolute value of y is less than, that means and, less than 7. So we're going to go ahead and make it 7 and negative 7. Now we have to do the rest of it. The part inside the absolute value stays the same, y and y. But what we have to do now is determine the right sign. When it stays positive, the sign stays the same, less than. But when the 7 turns into a negative 7, you got to flip that sign around. You get y is greater than negative 7. Now, most of the time, an and statement is going to be a line segment with a beginning point and an ending point. So when you actually turn this into a compound statement, you just look for your smallest number. The smallest number is negative 7. So I'm going to start that at the left, negative 7. But negative 7 is less than y. Y is the greater one. So I'm going to put the y right here. Negative 7 is less than y. I just turned that one completely around. But at the same time, y is less than 7. So I can finish the statement with that. So all you need to do is show where your negative 7 is. 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7. And you make your graph. This one's less than, it's an empty circle. This one's less than, so it's an empty circle. And the y is between them. It's an and statement, so it just shows that they're joined in the middle. Alright, so it's the same idea with this one. It's greater, so that's going to mean or. I'm going to have my 5, which is going to keep the same sign. And I'm going to have my negative 5, which is going to make that greater than turn into a less than. Every time the number becomes a negative, you flip the sign. And what's inside the bars stays the same. X plus 2 is greater than 5, or x plus 2 is less than negative 5. So when we subtract 2 from both sides, we get x is greater than 3, or x is less than negative 7. Subtract 2 from both sides, negative 7. Most of the time when you have a graph like this for the or, just like in the previous sections, it's going to be two rays that are going away from each other. There's one case where they actually overlap, where it can be different. So we're just going to take that answer and graph it. We need to have a negative 7, 6, 5, 4, 3, 2, 1, 0, and then we need to have a positive 3, 1, 2, 3. So looking at these graphs, there's no filled in circles, there's no line underneath or equal to. So I'm going to make an empty circle at the 3. and it says x is greater, the arrow's pointing that way, so I'm going to make my arrow point that way. And here it says less than -7. It's an empty circle. And it's less than, it's going to the left, and it's pointing to the left. So everything shows that it's going to go this way. So the or statement usually looks like this, where they're pointing away from each other. For example 4. For the first one, think about it as we go. This says greater, so we're going to go with or. And we're going to make it greater than or equal to 12, or we're going to make it less than or equal to -12. What's inside stays the same, 2x plus 4 and 2x plus 4. So all we need to do now is solve them individually and then graph them. So -4 on both sides of this one, we have 2x is greater than or equal to 8. Divide both sides by +2 means I don't have to change the sign. I just have x is greater than 4. Greater than or equal to 4. Over here we subtract 4 from both sides. We have 2x is less than or equal to -16. We divide both sides by +2, so we don't have to flip any signs. And we get x is less than or equal to -8. So those are the two things we need to make on our graph. An or statement is most likely going to be pointing away from each other. And in this case, it's a solid circle, filled in circle at the 4. So we need -8, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4. And at the 4, I'm going to make a filled in circle. It says x is greater than or equal to, so I'm going to make it go to the right. And on the -8, it's a filled in circle because it says less than or equal to. So that number is included. That's why it's filled in. And then it says less than. It's pointing to the left. I'm going to go that way. And that's your or statement right there. And the last one's going to be the trickiest because this x is inside the absolute value bars and this x is not. So you just have to keep in mind you might have to go back and check them to make sure that one of them is not extraneous, or one group of them is not extraneous. So looking at this case, we're going to say x plus 6 is greater than or equal to 2x plus 10. That's the one where it stays positive and it stays the same. We look at this sign, greater means or. Greater means or. Then we're going to fill in where we make it a negative. X plus 6, I'm doing it on the opposite. I'm making it a negative, so I turn it around to -2x minus 10. So now I'm going to solve each one. I'm going to subtract x so that my numbers will stay positive. And on this side, I can subtract the 10. And I have -4 is greater than or equal to x. Now, if I try to graph this, my rules won't follow because x is on the wrong side. So I want to turn the entire thing around. So x is, and you have to make the open end still towards the 4. So I'm going to turn it all the way around and make it x is less than or equal to -4. If you flip it around, you have to flip every single thing around. Or, on this side, we're going to add 2x to both sides so it stays positive. And then we'll go ahead and subtract the 6, and we get 3x is less than or equal to -16. When we divide by +3, we don't have to flip anything, but we're going to go ahead and turn it into a fraction. -16 divided by 3, dividing both sides by 3. Well, in reality, that's the same as saying -5 and 1/3, and that's going to be easier to find on the graph than -16 over 3. So these are the two numbers we're going to graph. So I'm going to start at the -4, and I'm going to make a filled in circle. So zeros here, 1, 2, 3, -4, and then -5. So I'm going to start at the -4, make a filled in circle, and my arrow is going to be to the left, less than. It's pointing to the left. And now I go to my negative 5 1/3, but you'll notice that that's already included. It's already there. So if you draw an arrow to the left, it's still within the same thing. Nothing has changed. So this first part right here actually encompasses the whole answer. The word or means that you don't look for where they overlap. You look for the one that includes the most possible answers. So the one that starts at negative 4 is the one that's going to have the most possible answers. So in reality, this one is kind of extraneous. It's just not necessary to graph it. The final answer is everything that's negative 4 or less.